Year 12 end of year exam, paper 1, non-calculator, June 2022. 1A, show that 2n minus 1 all squared plus 2n plus 1 all squared is equal to 8n squared plus 2. Expand the left-hand side and prove that it's the same as the right-hand side. So expand 2n minus 1, you get 4n squared minus 4n plus 1. Expand 2n plus 1, you get 4n squared plus 4n plus 1. Add those together, you get 8n squared plus 2, which is equal to the right hand side, which is 8n squared plus 2. Therefore, equal. 1b, hence or otherwise prove that the sum of the squares of any two consecutive odd numbers is even. Well, we have taken two odd numbers, squared them, and taken their sum in the previous question. So 8n squared plus 2, we have got to prove that that is even. Well, that is equal to 2 brackets 4n squared plus 1. Well, the right-hand side is now a factor of 2. Therefore, right-hand side is even. Therefore, proved. The functions f and g are defined such that f of x is equal to x plus 3 over 4 and g of x is equal to 8x plus 5. Show that g of f of x is equal to 2x plus 11. G of f of x means you take f and put the result into g. So we're going to take x plus 3 over 4 and put into g. So we get 8 lots of x plus 3 over 4 plus 5. Expand the top, so we get 8x plus 24 over 4 plus 5. Which is equal to 2x plus 6 plus 5, which is equal to 2x plus 11. Therefore, proved. 2b, given that the inverse of g of f at some value a is equal to 4, find the value of a. So the first thing we need to do is find the inverse of g of f. So we know that 2x plus 11 equals y. Change x and y, so therefore we get 2y plus 11 equals x. Solve for y, so therefore we get 2y is equal to x minus 11. So y is equal to x minus 11 over 2. Now we know that that is equal to 4 and we want to solve for x. Therefore we get x minus 11 over 2 equals 4. So x minus 11 equals 8. So x equals 90. The first three terms of an arithmetic sequence are u1, 5u1 minus 8, and 3u1 plus 8. 3a show that u1 is equal to 4. With an arithmetic sequence, two consecutive terms give you the value d, the common difference. Therefore, we know that 3u1 plus 8 minus the previous term, 5u1 minus 8 is equal to 5u1 minus 8 minus u1. Therefore, we get 3u1 minus 5u1 is minus 2u1. 8 minus 8 is 16, is equal to 5u1 minus u1, 4u1 minus 8. Therefore, we get 16 plus 8 is 24, is equal to 4u1 plus 2u1. So we get 6u1 is equal to 24. So u1 is 24 divided by 6. So u1 is equal to 4. 3b. Prove that the sum of the first n terms of this arithmetic sequence is a square number. Well, we know that the sum of the first n terms is given by the formula S of n is equal to n over 2, brackets 2u1 plus n minus 1 d. We know that u1 is equal to 4. We don't know what d is equal to, but we can find d using two consecutive terms. So if we subtract 3u1 plus 8, and we subtract 5u1 minus 8, that is equal to minus 2u1 plus 16. We know what u1 is, so therefore we get minus 8 plus 16, which is equal to 8. So d is equal to 16. So we know that S of n is equal to n over 2. 2 times 4, which is 8, plus 8 lots of n minus 1. If you multiply that out, you get 4n squared. Now that is a square number, which is equal to 2n all squared. Therefore, s to the n equals a square number. Consider the function f of x is equal to minus 2 brackets x minus 1 brackets x plus 3. For x is equal to any real number. The following diagram shows part of the graph of f. For the graph of f, for a, find the x-coordinates of the x-intercept. Well, the function minus 2 x minus 1 x plus 3 is in the right form. So it's in the x-intercept form. So x minus 1 equals 0. Therefore, x is equal to 1. Or x plus 3 is equal to 0. So x is equal to minus 3. So the x-intercepts are x equals 1 or x equals minus 3. 4b, find the coordinates of the vertex. First thing we need to do is expand minus 2, x minus 1, x plus 3, which equals minus 2, brackets, x squared plus 2x minus 3. We now need to complete the square for the inside brackets. So therefore, we get minus 2 brackets x plus 1 all squared minus 1 squared minus 3, which equals minus 2, and in the brackets we will have x plus 1 all squared minus 4. Therefore, we get negative 2 brackets x plus 1 all squared minus 2 times minus 4 is plus 8. Therefore, the vertex is at minus 1, 8. 4c, the function f can be written in the form f of x equals minus 2 brackets x minus h all squared plus k. Write down the value of h and k. We have basically already answered this question because we've completed the square in the previous question. So we've got minus 2 x plus 1 all squared minus 8. Therefore, h is minus 1, k is 8. The following diagram shows the graph of y equals minus 1 minus the square root of x plus 3 for any value of x greater than or equal to minus 3. 5a. Describe the sequence of transformations that transforms the graph of y equals the square root of x for x is greater than 0 to the graph of y equals minus 1 minus x plus 3 for x is greater than or equal to minus 3. We have 3 transformations. The first one is this negative sign. What does it do? Well, that is a reflection in the x-axis. The second one is what does the plus 3 do? Well, that translates the graph to the left by 3 squares. And the last transformation is what does the minus 1 do? Well, that is a translation up and down, and because it is negative 1, it goes down 1 space. So the 3 transformations are 1, reflection in x-axis, 2, translation left 3 spaces, and the third one, translation down 1 space. A function f is defined by f of x equals minus 1 minus the square root of x plus 3 for x is greater than or equal to minus 3. 5b, state the range. Remember, the range is the output. If we look at our function, this part of the function, because x is always greater than minus 3, must always be positive. So that means you are always going to be subtracting a positive number from minus 1. So the greatest output is going to be minus 1. The range is y is less than or equal to minus 1 for x belonging to any real value. 5c, find an expression for f to the minus 1 of x and then state its domain. So we know that y is equal to minus 1 minus the square root of x plus 3. So the first thing we need to do is interchange y and x. Therefore we get x is equal to minus 1 minus the square root of y plus 3. Now solve for y. So therefore we get x plus 1 is equal to minus the square root of y plus 3. Swap sides to get a positive square root, so we get y plus 3 square root of is equal to minus x minus 1. Square both sides, so we get y plus 3 is equal to minus x minus 1 all squared. Minus x minus 1 all squared is the same as x plus 1 all squared. So we now have y plus 3 is equal to x plus 1 all squared. Therefore, y is equal to x plus 1 all squared minus 3. Now we have to state its domain. Well, the original function had a range of y is less than or equal to minus 1. Therefore, the domain of its inverse is x is less than or equal to minus 1. The domain and range of the original function and its inverse are the same. 5D, find the coordinates of the points where the graphs y equals f of x and y equals f to the minus 1 of x intersect. This is the grade 7 question on the paper. If a graph y equals f of x and its inverse f to the minus 1 of x intersect, they will intersect on the line y equals x. Therefore, we can say that f to the minus 1 of x equals x. Therefore, f to the minus 1x is x plus 1 all squared minus 3 equals x. Therefore, expand the left-hand side. You get x squared plus 2x minus 2 equals x. Therefore, x squared plus x minus 2 equals 0. Factorize the left-hand side. You get x plus 2, x minus 1 equals 0. Therefore, x equals minus 2 or x equals 1. We know from a previous question that x is less than or equal to minus 1. Therefore, x cannot equal 1. Therefore, x equals minus 2. Therefore, y equals minus 2. So point of intersection is minus 2 minus 2.